Here we go, round 2. This part we're going to talk about absolute values. As you probably already know, absolute values are always going to be positive, so we usually use them to talk about distances and magnitude. Which distance can be a magnitude. So when we talk about the expression, the absolute value of A, you could have A either be the positive value or a negative value. For example, you could have absolute value of 3. Meaning that 3 could either be a 3 or a negative 3 on the inside. Some things that you need to know, the absolute value of A, and I actually forgot to put the little symbols around it, is always going to be greater than or equal to 0. Okay, so it's always positive. Another thing is that if you have the absolute value of negative A, that means that can equal A. Some good or easy ways to compute with them, if you wanted to have or multiply A times B within the absolute value, it's the same thing as taking the absolute value of each of them individually and then multiplying them. Same thing with division. If you wanted to, you could split that up so that you were taking the absolute value of A first, then dividing it by the absolute value of B. Some quick examples, absolute value of negative 5 is going to be positive 5. So then if you're computing with this, maybe I would take the absolute value first, so that it's negative 3 minus the absolute value of 3, which is just 3. Which makes that a negative 6. Okay, so you got to be careful if there's a negative on the outside of an absolute value, because it's going to switch it back to negative. Variables, as you can see, there's a whole bunch of examples right here. Those are just going to be the letters in your expression or equation. Most common is probably X and Y, and is pretty famous too. Really, you can use your favorite letter, usually lowercase. And then we're going to also talk about or deal a lot with this year the difference between an expression and an equation. An expression has no equal sign, so no equal sign. An example of that would be like 5x plus 2. If you wanted to make that an equation, you could say that it is equal to y, something like that. Right, so no equal sign in it at all. So down here, these are some algebraic properties. You did do a lot of these probably in Algebra 2 and in Algebra 1. I was just going to kind of breeze through these really quick. If you need to stop the video, rewatch them, you can. This last column, I was just going to put some numerical examples. If you have these down pretty well, you can see, try out, the reflection sheet, see if you got those. And kind of skip forward in the video if you want. So the commutative property, it doesn't matter if you add A first to B or then B first to A, they're going to end up being the same thing. 2 plus 3 is going to be the same thing as 3 plus 2. Same thing with multiplication. You can have A first or B first. They're going to equal the same thing. Okay. Associative property, here they're kind of associating with different numbers first. It doesn't matter because it ends up being the same value on each side. For example, if you add A to B first, then add it to C, it's going to be the same thing as if you were to add B and C first and then add it to A. So let's try that real fast. So if you have like 2 plus 3 and then add 5 to it, see. It's going to probably be the same thing as taking 2 and then adding it to the sum of 3 and 5. Let's see, 5 and 5 make 10. And 5 plus 3 is 8, plus 2 is 10. It works out. Okay. Same goes with multiplication. I'm going to use a variable to kind of split things up. If you have 2x times 3, it's going to be the same thing as if you were to do 2 times the value x times 3. They're all going to equal 6x. Okay. The distributive property, this is just where you take the multiplier on the outside and distribute it, or multiply by everything on the inside of the parentheses. A quick example, I am going to still use variables. You would just take the x on the outside and distribute it to every value on the inside of the quantity. So that each one is multiplied by the x. Excellent. Here we're going to have some identity properties, and same with the ones. These are actually going to show up a little bit later, so you get a little repetition with it. Identity property, if you think about your identity, you are yourself no matter what, even if you were to add 0 to yourself. Don't know if that makes sense, but pretty much in the start and the end, a value is the same. So for example, if you were to take 7, add 0 to it, you end up with 7. Right. Multiplicative identity, the only way to get what you started with is to multiply by 1. So if you were to take 7, multiply it by 1, you will end up with 7. So those are the identity properties. These two, the inverse properties, they're going to be inverses because you're undoing what's been done, sort of, just to start off at 0 or 1. Or end up at 0 or 1. For example, if you take a positive value, let's say 8, and then add its negative value, you're going to end back up at 0. Here, the multiplicative inverse, you're going to take a value like x. How about that? If you wanted to multiply that by 1 over x, you're going to end up with 1. A numerical value, if you were to take 2 times 1/2, you end up with 1. Moving on, some properties of negation. These really just stem off of the distributive property and the identity property. Here, this is similar to the multiplicative identity property, although it's not an identity property because you end up with a negative value as your answer. Any number times -1 takes that number and makes it negative. Here, if you were to distribute a negative into the parentheses, you're going to change that value to positive. Let's see. So this just becomes like if you had -2. Good thing I have erasable pen. And then multiply by -1, you're going to get +2. Here, this is kind of like the commutative property. It doesn't matter what order you multiply things in. They're all going to be the same. Pretty much if you have a negative number times a positive number, your answer is going to be negative. And then the last couple, let's see. Oh, negative times negative makes a positive. You guys are pretty well versed with that. Last one's just the distributive property. If you have a negative on the outside, I know that you've been told this all the time, but this is like the #1 problem or big mistake in math. And just make sure that you just distribute the negative to both of the values on the inside. Similarly, if you started off with a negative, like for your second number, make sure that that turns positive. All right, awesome. Got that page done a little bit faster than the first one, so we'll keep going. Properties of 0, we already talked about the identity property, which is the first one. And take anything, add 0 to it, or subtract 0 from it. You'll end up with the same thing. So that's identity. Take anything, multiply it by times 0. I'm sure you know ends up being 0. So 8 times 0 is 0. Anytime you have a 0 in the numerator, your answer will be 0. So how about 0 over 12? You can't divide 0 up into 12 different groups. Here, 0 on the bottom, it's just a bad mess, okay? Don't ever say that this is 0. Maybe put a star next to it. Anytime you divide by 0, it's undefined. So let's see, 12. And actually, if you go to your calculator, if you ever are wondering, you're not sure, you get these mixed up a lot, go to your calculator, divide something by 0. It should say error on it. Okay. The zero factor property we're going to use a lot when we talk about zeros of a polynomial. If you have two multipliers, like a times b, and they're going to equal 0, one of those has to be 0. A way that you've seen this before, if you have like a factored equation, like x minus 2 times x plus 5. And I asked you to find the zeros of the polynomial. What you would do is set each of those equal to 0 and solve for x. Equals 2. And that is just that property in action. Some more properties that talk about fractions. I would say maybe take some time, look over fractions. I know fractions are a bit daunting because they're not just those perfect easy numbers to add and subtract. But these are on the book. They're good to know, really, especially when we get to trig. So let's see. Let's go over some equivalent fractions. This one's pretty neat. If you have a over b equaling c over d, it's kind of like cross multiplication. That's really what it is. You can just, let's see, like if we had 1/2, you can use it for proportions, x over 10. It's the fact that you can take 2x and set it equal to 1 times 10 and solve for x. This one, it doesn't matter what the placement of the negative is, if it's in front of the fraction, if it's in the top or the bottom, they're all the same. Okay, so like negative 1/5 is the same thing as negative 1 over 5, which is really going to be the same thing as 1 divided by negative 5. All right, all equal. And you can give it a go in your calculator if you want to try. You should end up with the same decimal. The last thing, if you have a fraction and you maybe use this a lot when you're trying to get common denominators, let's say we're doing 1/2. If you want to, I don't know, change that 2 so that it's a 10, you can take the top and bottom, multiply it by 5 to get 5 over 10. And they're just really equivalent fractions. It's kind of like reverse reduction when in terms of fractions, like 5 over 10 is the same thing as 1/2. Adding and subtracting, this is the big thing. When you add and subtract denominators, you need to have this bottom number be the same. If it is, like in this case, they're both b's, you can combine over one denominator. So for example, 3/2 plus 5/2 is the same thing as 3 plus 5 over 2. All right, you can go ahead and add them since the denominators are the same. Here, you need to have common denominators in order to add them or subtract them for that matter. And it kind of gives you a quick way of doing it. I'm going to keep using variables just for this example. I know there's variables over here, but all the a's and b's kind of get sloshed together after a while. So let's see. If you want to make a quick common denominator, just combine the two denominators via multiplication. And then just take each denominator and multiply it by the opposite numerator. For example, 3y plus 5x should do it. Last couple. Multiplying fractions, just multiply straightforward. Dividing by a fraction is the same thing as multiplying by its reciprocal. So for example, if you have 4 over 9 and you want to divide it by 2 over x, it's the same thing as doing 4/9 times x over 2. All right, I'm kind of running out of time, so I just want to quick put this in. If you have an expression, add something to one side, you have to add it to the other, so that's addition. Here, if you have an expression and you multiply one side by c, then you have to multiply the other side by c. Here, if you have an expression you want to take away c, then you need to do it to the other side in order to keep it the same. Here, you have an expression you want to get rid of c on this side, so you divide, then you have to do it to the other side to keep it equal. All right. last couple of minutes. Prime factorization, if you think about a prime number, it needs to be only divisible by itself.